Hey everyone, Chang here and welcome to my channel. Today I'm going to talk about the silent killer of algebra word problems. These are the type of problems where you look at it, you think you got it, everything's great, you work on it, you send it in, and then when you get your test paper back, you got an F and you're like, what the hell happened? Those are the problems that we have to worry about because it looks like it's asking one thing, it might be, but it actually ends up being another. These are the rate problems, or otherwise known as the distance rate problem. So, distance rate problem. Distance rate, sometimes distance rate time problem. Now, these type of problems, they're usually asked in one way or another. Of course, based on the title, they're going to ask about distance. Rate is usually what we're talking about in terms of miles per hour, or in other variations, when they're not talking about distance, they're talking about work. And what I've seen, they love, for example, moles digging a hole. They love painters painting a wall. They love builders building, gardeners gardening, stuff like that, where you're working at a specific rate. So it's going to be, something per time, usually per hour or per seconds, depending on the problem. Be very careful of that, right? That's rate. And then, of course, you have your time. Distance might not always be distance. Sometimes, as I mentioned, the variation is going to be work. Right, some form of work, painting, gardening, digging, so on and so forth. So these kind of problems are difficult because it looks easy and then we end up misinterpreting the problem. So we really have to read these problems carefully and work through it. Now, for distance rate time or work rate time, there's actually two kinds of equation that they sort of expect you to know. The first one is D equals RT and variations of such. D is distance, R is rate, and T is time. Not that difficult, right? They'll probably ask you something like R equals D over T or T equals D over R. Same thing. The other one is the variation is going to be W equals RT. And oftentimes you'll see W equals RT with an M. I'm just going to put the M in red so you guys can see. It's slightly different, right? The M stands for multiple. Because what they love more than anything is when they ask you a problem about, work, rate, distance, so on and so forth, they'll add another helper. So instead of one person digging a hole, now you have three person digging a hole. How fast are you going, or how long it's going to take? That's what you got to be careful of. So you have your regular distance equals rate times time, and then you have the other one where work equals rate times time, and then sometimes you would need the M, which is multiple. All right, so let's look at some of the problems and how we can solve it using these formulas, and how we can solve it just sort of brute forcing it. All right, so for our first problem, we have this. Bob runs 4 kilometers to school in 25 minutes. After school, he walks the same way home in 55 minutes. What is his average speed for the round trip? Now, looking at this problem is actually kind of interesting when they use the word average speed, right? It could be potentially confusing. When we think of average, the first thing we're probably jumping at is we're looking for at least 2 numbers or more numbers, add them all together and divide by the total numbers that are added. In this case, it's not really what it means. What it's talking about is that basically you have 2 different speeds. When he runs to school in 25 minutes, clearly he's going a lot faster. But after school, he's just walking. I guess he's not in any hurry or anything. And now it takes him 55 minutes, so he's clearly walking a lot slower, right? These are 2 different speeds. The average speed is just talking about, like, if you're factoring into both, I guess you could say, trip, when he goes and when he comes back, right? And those 2 different speeds, what is the, I guess you could say, the middle ground of those speeds? So, for a problem like this, and with the equation that or formula we know about, D equals RT, distance equals rate times time. What we can do, actually, is start filling things out. Distance, in this case, is actually 8 kilometers. The reason for 8 kilometers is because, well, guess what? It's a round trip. You go 4 kilometers to school and then 4 kilometers back, going the same way, right? So that's one potential hiccup. Distance is not 4, it's 8. Even though in the problem it says 4, your round trip, 8, all right? So we can say 8 kilometers, and then that's going to equal, the rate is what we're looking for. The rate is usually per time, right? Average speed. In this case, is most likely going to be per hour or per minute. So we're going to leave rate as it is because we don't know what that is. And it's going to be R. And T is basically both. Remember, round trip. One trip, he took 25 minutes. The second trip, he took 55 minutes. So when we add them together, technically that is what? 80. Right? 55 plus 25, 80. Yes, 80 minutes. Okay, and there it is. And then we're solving for the average speed. In this case, 8 divided by 80, so it's going to be 8 over 80, because we're, dividing this to get rid of here. We're looking for R. Forgive my poor penmanship. Basically, this is what we have right here. So R is going to be, well, if we simplify it, 8 over 80, we can actually do 1 over 10. Don't forget our units. It's 1 kilometers per 10 minutes. And of course, people don't really like that. They probably want it in hours. So what you're going to do is you're going to convert this into hours. In that case, you're going to multiply top and bottom by 6. By 6. By 6, and that means you're going to have R equals 6 kilometers, and then 60 minutes, right? 6 times 10 is 60, right? It's technically 1 hour. So 60 or 6 kilometers per 1 hour. So that's how you would solve it using the formula, the SMART method. Let's go over it again, except for using more of an intuitive understanding, or at least how I approach solving it when I first saw the problem. All right, so when I first saw this problem, I mean, my intuition or my first instinct wasn't to just jump at the formula. Of course, like I said, these are silent killers. They show up in places when you don't really expect them. So, that's the tough part about it. So what I did is I just tried to understand the problem first. I just drew this little poorly drawn diagram, assuming the road is just completely straight. No hills, no nothing. It's that when Bob runs his first trip, right, his first trip to school, well, it's going to be 4 kilometers. And I know that it took him 25 minutes. And then I know that it's a round trip, so he went back. So I just assume instead of turning around and going back, he just took a total of another 4 kilometers, which is 8 kilometers. And it took him 55 minutes this time. And I remember that average speed means that I don't take into account their individual speed, but I want to find just basically the middle ground of this entire trip. Well, if I add them all together, I just know that right here, it's going to take them 80 minutes for this trip. And at the bottom, it just took him 8 kilometers. Right? And so I want his average speed. And then if that's the case, I can just start, I guess you could say, simplifying it. Well, if I look at this, 80 minutes is 8 kilometers. That means 10 minutes is 1 kilometers. I don't really want that. I want it in hours. So if I want to change this into hours, I know I need 60 minutes. So if I multiply, I guess, the ratio or the both of them by 6, then here you have times 6 times 6. That's 60 minutes, which is 1 hour. Let's just do 1 hour right here. And this one's going to be 6 kilometers. And just like that, I figured out that it's going to be 6 kilometers every hour, or 6 kilometers per hour, right? And without the actual formula coming in the forefront, I was still able to solve it. So that's another way to go about this. It doesn't mean that you have to necessarily remember the formula. Of course, if you remember it, if I remembered it the first time I saw this, solving it would be great. If not, at least just try to understand the problem, intuitive it out, and then just, brute force it. See what we got, what we want to know, and then just start working, chipping away at it, and then eventually we'll get the answer. Let's look at the next problem. All right, so for our next problem, we have this problem right here. It takes 6 minutes for 6 painters, grammar, right, to paint 6 walls. How long will it take 7 painters to paint 7 walls? Well, I mean, when I first saw this problem, needless to say, I made a huge mistake, huge blunder of my basic assumption, gut feeling, all right? I saw 6 minutes, 6 painters, 6 walls. How long will it take 7 painters, again, grammar, to paint 7 walls? Well, 6 minutes, 6 painters, 6 walls. Intuitively, 7 minutes, 7 painters, 7 walls. Wrong answer, right? That's the thing. With this kind of problem, it's basically the other formula. If you want to solve it using formulas, right? Our work in this case, because there's no real distance we're actually working with, right, is again, rate times time, except for now, we're talking about multiple painters. Notice that. So we actually have multiple as well, so with the M as well. So what do we have? Well, if we're going to solve this, we're going to have to figure out some of the missing information. In this case, we know that we have 6 walls, work wall, whichever one you want to use W for, right? We have rate, which, do we know? No, we don't. All right, so we don't have rate. We know that it takes them 6 minutes. And we also know that there are 6 painters. Okay, and so ignoring everything else, we're trying to find R. Well, if that's the case, 6 times 6 is 36, and so we have 6 equals 36R, and I'm gonna just take away for the units so that it doesn't like run on. But 36R, and then we're gonna divide by 36 on both sides. All right, divide by 36. That simplifies to R equals 1/6. And now, even though I took away the units, we kind of know what it is, right? Basically, we're talking about rate, so how fast it takes a person to paint. So it's going to take, I guess you could say, 1/6 wall per minute. Okay, so that's our rate for one painter. All right, well, if that's the case, how long will it take 7 painters to paint 7 walls? Now we got to use this formula again, except for ignoring all the previous information, we're plugging in new information. Well, the first one, wall, is 7. We're painting 7 walls, right? The second one, our rate now, is the rate that we found, which is going to be 1/6. And then we have time, is what we're looking for, T. Let's just make it red here so we can see it. And the last one, multiple, we know that we have 7 painters. So we're actually multiplying by 7 in this case. Well, if that's what we're going to do, we're going to just simplify it. Well, first and foremost, 7, just to simplify, we can divide by 7. Divide by 7, divide by 7. This goes away, this goes away. So now we have 1 equals 1/6T. So we're going to multiply by 6 on both sides. This goes away. We have T equals 6. Remember that we're just talking in minutes. So it's going to take 7 painters 6 minutes to paint 7 walls. So let's look at this in a more intuitive or brute force way, right? We're going to try to understand this problem, chip away at it, and hopefully we'll come up with something. And if we end up with having to use the formula, then that sucks. But I feel like we can actually solve this without having to use the formula. So after making that blundering error when I first approached this problem, the next thing I did is I just tried to basically break it down. Now here's the basic assumption with painters, right? This is assuming that all the painters are working harmoniously together. They are not interfering with each other in any way, you know, having little spats. They're just working and they're like super in sync. So I'm going to assume that. Well, first and foremost, we have 6 painters and 6 walls. So being the lovely artist that I am, not really, right? We have 6 walls. Hopefully I can count correctly. All right, there we go. 6, 1, 2, 3, 4, 5, 6. All right, cool. And then each of us, we have our little painters. And this is the 4th one, this is the 5th one, and 6 painters. All right, there we go. All right, 6 painters. They're all working on a wall by themselves, so they're not interfering with each other. Great. All right, so we have 6 painters, 6 walls, and it takes them 6 minutes. Well, just like that, it means that in 6 minutes, each painter is painting 1 wall. Simple as that. Well, if that's the case, then if I had 7 painters and I want 7 walls, I'm just going to add another wall. And I'm going to add another painter. And assuming that painter is just as competent as every other painter, I mean, they should be painting at the same speed. Well, if that's the case, then it's going to be, well, 7 painters, 7 walls. Their speed shouldn't change, right? Each of them are still painting a wall. And still should take them each 6 minutes to paint that 1 wall. Therefore, how long will it take 7 painters to paint 7 walls? Well, 6 minutes, right? Each one wall. We're good. Alright, so we have our next problem right here. Now, the only real difference other than, you know, the actual problem, the underlying structure is the same. The numbers are different, right? The numbers are not as confusing as the other one where it could potentially lead you to immediately jump to conclusions, right? This one is clearly very different. So let's just start working on this very quickly. We have 9 super robots. Grammar. Can build a building in 5 hours. How long will it take 15 robots to build 3 buildings? Buildings, right? And yeah, all right, cool. So here's what we're gonna do. 9 super robots can build a building in 5 hours. Remember, we have our variant of the distance, rate, time, which is our work, rate, time, and multiple, right? We have the M as well. Well, in this case, we know that a single building, so rate, that's just 1 right here. And our rate, we don't know. We need to figure out the rate. We know the time is 5 hours. And we also know that there are a total of 9 robots, right? In that case, this is what? 5 times 9 is 45. Technically, we have 1 equals 45R. Divide by 45 on both sides, right here. 45, 45, this goes away. Now we have basically R equals 1 over 45. So basically the rate for one robot in terms of building a building is 1 over 45 building per hour. Which seems kind of an odd way of phrasing it, but I mean, what can we do? Okay, there it is. Now we have our rate. What we're going to do is we're going to see how long it will take 15 robots to build 3 buildings. Same formula. Now instead of 1 building, we're doing 3. So 3 equals our rate right here, 1 over 45. Our time is what we're looking for, right? So we have our T right here, and our multiple, now we have 15 robots, right? Yes, 15 robots. All right, well, here we have it. We have 3 equals, we can simplify this, 15 goes into 45 3 times. So it's going to be 1 over 3 times T. Well, in that case, we're just going to multiply by 3 on both sides to get rid of the 1/3. This goes away. We have T equals 9. Well, in this case, we're talking about 9 hours. So it's going to take 15 robot 9 hours to build 3 buildings. Now that's how you solve it with the formula. Let's see what happens when we try to brute force this. So we're looking at this problem again, and now what I'm going to do is try to understand this problem very quickly. We have this one building, let's draw it like that, and we have 9 robots that can build it in 5 hours. Well, in that case, well, let's just break it into like 9 different parts. 1, 2, 3, 4, 5, 6, 7, 8 dividers should have 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, 9 different parts. I'm not even going to attempt to draw a robot because I am terrible at drawing, as you can see from the previous problem, right? Well, there's 9 different parts, so it's going to take technically 1 robot 5 hours to build 1/9 of the building, right? Because it took 9 robots 5 hours to build the entire building. 1 robot 5 hours to build 1/9 of the building. Well, if that's the case, let's see what happens. Well, if we want to see how long it's going to take him to 1 robot to build, or how much they can build in 1 hour, in that case, we're just going to divide these guys by 5. Technically, 1 robot, and then we're looking at 1 hour now. Right? So in 5 hours, it can build 1/9 of a building. If we divide this by 5, technically in 1 hour, you can do 1 over 45 of a building. Hey, this looks familiar. All right, cool. Excellent. Now, in that case, what do we know? 1 robot, 1 hour, 1 over 45 of a building. Well, if that's the case, let's just say what happens if we're working with 15 robots. So all this should be good. Let's multiply this one by 15. So now it's 15 robots. Right, and they're all still working 1 hour. And then this one, well, multiply by 15, you have technically 1/3 of a building. Cool, getting closer. 15 robot will take 1 hour to build 1/3 of a building. Well, if that's the case, what happens in 2 hours? In 2 hours, this 15 robot is going to build, well, let's see, 2/3 of a building, which makes sense. Three hours. Same 15 robots. It's going to build 3 out of 3 of a building, or technically 1 building. Ah, now we're getting somewhere. This is what we need, right? Even though we're sort of grinding away. 15 robot takes 3 hours to build one whole building. Excellent. We need 3 buildings. If it takes them 3 hours to build one whole building, guess what? In 6 hours, it's going to build 2 whole buildings, and in 9 hours, it's going to build 3 whole buildings. So just from that, and we can sort of like reason it out, it's going to take these 15 robots 9 hours to build 3 of these guys. All right, so now that we've solved 3 problems in basically 2 different ways, one with the formula and one without the formula, is one necessarily easier than the other? Not really, right? Some of them, the formula saves us plenty of time. The other one, not so much, right? Just intuitively understanding and chipping away at the problem actually saves us a little more time and prevents certain errors. Well, if that's the case, do I recommend one over the other? No, I don't, right? If you can remember the formula and you feel more comfortable using the formula, great, more power to you. Just make sure that you can see it at the opportune moment when you see problems like these, right? If not, try to understand the problem and solve it in whichever way possible, right? Thank you for watching this video. See you in the next one.